Hi all. Last year I purchased this socket fan and light, and I did not like how the original plates look because they look too much like a flower to me, and well, I don't like that. So I did what I do best and create custom plates for it, as you can see here. Now these plates are made of plastic sheets and they are attached to the motor with custom 3D printed blade arms. They are screwed on, as you can see. It actually worked very well. Airflow isn't actually as much as with the original plates, but because the diameter is bigger with these plates, 26 inch versus 20 inch, the airflow is more spread out, and I like it that way. And that actually got me thinking, does this material work well with a full-size ceiling fan? So in this video, I'm going to do just that. I'm going to make a full-size ceiling fan with plastic plates to see how the material holds up over time. In the 3 months that I've used this fan with these custom plastic sheet plates, I noticed that the plates are starting to sag, as you can see here. This plastic sheet here isn't the strongest. It is in fact quite flimsy. And I'm afraid if I were to make fan blades that are longer than this, it will sag around the blade arm area and break in no time. This here is a 2mm thick plastic sheet, and to counter the sagging problem, I'm going to use a thicker sheet. In fact, this one here. This here is a 3mm thick plastic sheet. I bought 2 of them. This third one is leftover from this project. And obviously this 3mm thick sheet is more durable and less flexible than the 2mm, as you can see here. I'm going to use this motor here that came from a cheap ceiling fan, and I'm going to start small. I'm going to make a blade set for a 36-inch diameter ceiling fan. If the material turns out to be durable over time, say 2 years or so, I might make a 48-inch variant of that ceiling fan with the plastic plates, and I don't know. I'm just going to do R&D for this video mostly, and if you want to follow along, let's go. I'm going to make the design, which you will see shortly, and make the plates and try it out. So here's the design that I have made on CAD. As you can see, it is quite geometric, a lot of hard lines on it. That is because I cannot easily make curves on this plastic material. I don't want to risk breaking it, but I can easily bend it by scoring lines on the back side of the material and then bending it with a jig, and then filling the scored lines with super glue to strengthen it. So what I'm going to do now is print these designs on paper, use them as a template to cut them out on a sheet of cardboard, and then try it out on the motor, see how it looks. And if I like it, I'm going to make this design on the plastic sheet. So here we go. Alright, a few hours have gone by, and in that time I have created 2 cutouts. One of them is used here as a test fit. I wanted to see how the blades look with the motor installed on it. Yes, I made a cardboard cutout of the blade arms and screwed them on to the blades. I just wanted to see how they look. So yeah, this area right here is going to be bent down, while this area here is going to be bent up as sort of a like a curved blade ceiling fan. The other cutout is going to be used as a template. So as you can see here, the holes are not yet punched through. I'm going to punch them through with a small needle so that I can trace it out on a well, for this one on a piece of steel, and this one on the plastic sheet. And yes, I'm going to make the blade arms out of steel. Specifically, these pieces of steel, which are cut-offs from industrial ceiling fan blades, which you can see here. This tag here came from Advanced branded ceiling fans. This tag came from Nikos, I believe, as well as these. And this one from Panasonic ceiling fans. This piece here is big enough for my blade arm template. So what I'm going to do is trace the template out on these three pieces, cut them out with my mega scissors, and then drill the holes. But first, let's tackle the fan blades. Alright, before I get too far, I figured I'd better test how easy it is to bend this material, because I don't want to score a line and then bend it and find out that it breaks. So, what I'm going to do is, this is a small cutout that I sliced off from this board here. I'm going to try two cuts. Both of them is going to be on this surface, but one of the cut is going to be bent down and the other is going to be bent up, because I'm going to use both downward and upward bends on this material. So, get my ruler and let's score a thin line. Apply moderate pressure. Let's do it twice. See if it's deep enough. No. Okay, one more score. Let's try with other ruler. Alright. Now, the other line. So now that I have to score 3 lines. 1, 2, and 3. Okay. Now, what I'm going to try is putting my ruler on the scored line here and bend this back. Let's try this. I'll pull this back a bit. Okay, so it's not working because I think I need to cut a V groove on here. So let's try that. Again, this is experimental. I've never done this before, so you are figuring things out with me. So now, let's pull this back. Okay, that's a bit difficult still. I wonder if I need to score the opposite way. Let's try this. Okay, now there is somewhat of a V groove on there. Okay, so that's as far as I'm able to bend it. I fear that I'm going to break it. Okay, so I think that should be enough for what I needed. So now let's try the other cuts. I'm going to put my ruler underneath the material and bend it this way, like this. Okay, that was significantly easier. And that's a pretty clean line. Okay, now let's get to cutting. Alright, so now all three blades have been cut, but before I do any sort of bending on them, I need to drill the holes for mounting the blades on the blade arms. I'm going to be using these 5mm bolts, and before I drill them with the 5mm drill bits, I'm going to drill a pilot hole first, so that the holes are centered. But before that, I need to center all these three pieces first, so that the holes are right where they should be. Okay, that's good enough. Place them on this cardboard here. Minor adjustments. Okay, let's go. Okay, now all three blade arms are cut, and my arms are sore, so I need to take a break. Alright, a day has now passed, and in that time I have drilled the holes on the blade arms and added pitch to them, as you can see here. I did this by clamping two pieces of wood, one above and one below the blade arm, and then bending it with the help of those pieces of wood for leverage. Now comes the fun part of bending these pieces of plastic. Alright, so now that the areas where the bend is going to be placed have been scored, as you can see, there are 10 lines over here and then a V groove over here on all 3 plates. I'm going to bend them by using this jig. As you can see, there's this T on it, also an S. T is for the plate tip, while the S is for the surface. And so that the bends don't instantly go back into place, I'm going to use super glue to make sure that the bend here stays in place permanently. So here we go. So first off, I'm going to start with this bend. Use the T part. I'm going to place the jig right about here. Place the super glue and then pull this up. So let's do that. Okay, that should be good. And then okay, immediately I've learned that I did something wrong, which is when I put the super glue, it immediately hardened and it's now stiff. So it's a bit difficult to pull this up. So next time what I should do is pull this up, hold it in place, and then pour the super glue. Okay. Okay, now to bend the surface of the plate, I have modified the jig slightly by gluing this extra piece on the bottom. And as you can see, there's this little accident that just happened here. Basically, the story was I accidentally dropped hot super glue on it, laid this plate on top of it, and then yeah, no matter. So how I'm going to do this bending job is I'm going to place this plate like this, so the this edge of the plate lines with the edge of the jig, and I'll press this edge down while applying the super glue. And now we wait again a few seconds, and the joint has hardened, the glue is hardened, and the plate is finished. And done. As you can see, it is definitely an interesting looking fan. From my point of view, I think the blades are a bit too wide, especially on the root, but proportionally, I think it is pretty cool. So now let's test it. Let's crank the speed out slowly. Here Here's speed number 1. Now, I made the blade tips curved up so to reduce the amount of tip vortices that happens on the edge of the blades. And my hope is that this fan here can be completely silent, if not very quiet, especially because the thick material there helps reduce the whooshing sounds normally associated with industrial ceiling fans. So let's see if it's true or not. Putting it to speed number 3. Unfortunately, the bearings on the motor there is a bit worn, so you might hear a bit of a ticking sound. It's pretty promising so far. In terms of airflow, it's very good already. Now let's pop it into high speed. Okay, that is very, very satisfactory. It is very quiet. I'm pleased with that. Airflow wise, it's pretty strong. In comparison, here's the performance of my Artner Basic 36 ceiling fan. This is also on full speed. When I first made that Basic 36 ceiling fan, I thought the noise was very reasonable because the material is thicker than I usually find on cheap ceiling fans. But this fan blows it out of the water. Definitely. Here's a close-up view of it. Here you can see the blade pitch. It's not the deepest, but it is quite deep. Top view. And yes, the canopies are mismatched and upside down. Both of them. I grabbed whatever I had on hand. And here's a close-up of the blades while the fan is off. As you can see, it is screwed onto the blade arm, and yes, the screws are all pointed on the same direction. That's just how I am. Here's the view of the blade pitch from the side. It is certainly very unique, especially with the triangular curved tip there. You can see the side profile here. So overall, this has been a very informative project and a fun one too. I would certainly make more of these plastic blade ceiling fans in the near future. And I really do hope that you learned as much as I did from it. For now, see you on the next video and take care.